This one I'm just going to change it up a little bit. Do something that we haven't seen yet before. Is we're going to have the one object coming towards the other object instead of moving at speeds in the same direction, or this one sitting still. We're going to have it sort of put in reverse. So you're going to go and run in the back of this car. They put it in reverse and hit you. You might see this in a smash-up derby, if that's what they still call them. So how do we deal with this? Same thing. We're always going to start with momentum. Momentum before equals momentum after. The nice thing is that we see that they stick together by my drawing there, and that's going to help us with final velocity. But how we deal with this? Well, if we call positive to the right, we have to make that a negative. So mass times velocity, this will be 1,000 times 10 plus this will be 500, and this is where we make it a -2 because it's going the other direction. And then it's going to be, since they stick, they add together, become that. Okay, so how's this work out here? 10,000 becomes a -1,000 equals 1,500 V final. That's going to give us on that side, what, 9,000 is 1,500, so 9,000 divided by 1,500 equals 6. It's convenient. And it's still positive, which means after the collision they still are going to be moving to the right. Now that typically happens, and you could use this when you sort of look back at your problem. This is an object that's twice as big as this one, and it's going faster. The bigger object tends to win in a collision. That sort of makes sense. You'd rather be in a dump truck than a I don't know, a little Volkswagen or something. They tend to win. Now, win in that the final velocity is closer to what they are doing. So this car goes from a 10 down to a 6. This goes from a -2 up to a +6. So this one experiences more of the change. They decelerate and then re-accelerate, which is what kind of whiplash is. And this one just accelerates. Alright, real quick, let's look at the energy here. While we got a few moments, that's going to be half mv squared plus half mv squared initially. Half 1,000, that's 10 squared, plus half 500. Now it's -2 here, but since it's squared it sort of falls out. It's half, that's 100, that becomes 50,000 I believe. Plus half, that's 4. Half of that is 1,000. 2 times 1,000, so that's 51,000 joules of energy. Energy after half mass total V final squared, because they stick. It's half 1,500 V final 6 squared. That's going to be 18, because 36 squared divided by 2. 18 times 1,500 equals 27,000 joules after the collision. So the change in energy, which tells us the energy lost, will be 27,000 minus 51,000, which should give us 24,000, and it's a negative, and that tells us that the energy is lost. So it is a inelastic collision in that the objects do lose energy, and that energy we expect goes to deformation, probably just a little bit of sound, but mostly, predominantly, deformation. So, alright, there's a good problem where the object is going, or they're going at each other. Hope that helps. We'll see you next video.